Hi, and welcome to Charter Conversations. I'm Drew Damico, president of Building Hope Real Estate. And today, my guests are Joseph Khoury, co-founder of MCN Build, a general contractor located in Washington, D.C., and Raj Setty. Raj is the founder and president of Setty Associates. They're also located in Washington, D.C. With all the concern about students going back to school in the fall, Raj and Joseph are experts in building and design, and we are very lucky to have them and to get their advice today. Good morning, Raj and Joseph. How are you?
Good morning, Drew. It's good to see you.
Good morning, Drew.
It's nice to see both of you. Thank you for coming to talk to me today. I'm really looking forward to our conversation. Joseph, your firm, MCN Build, is the go-to firm for schools in Washington, D.C. Tell me a little bit about MCN today, because I have gotten to know you over the years, and you started out doing charter schools, and you've now become, as I mentioned before, the go-to firm for schools in the Washington, D.C. area. How did that come about, and what's going on with MCN today?
Well, we've been very, very fortunate. In 2007, Rudy, Bassem, and I got together around 2006, 2007, and founded MCN. And honestly, the common denominator that kept on coming up between us when we were trying to think about what we wanted to focus on was the community. So if you were to look at our portfolio, about 80% work touches the community in one shape or form.
What is construction like today for you and your partners and the 110 employees that you have, given that you're in a delivery season for schools? How are you adjusting?
Well, the adjustment is both personal and professional, as everybody else that might be listening to us. I'm a father of two kids, 9 and 6, and my wife runs a business as well. So it's been a lesson in humility and patience and adaptability since this whole issue started. Just to find a quiet space at home where we can have a conversation like this, or trying to get a 6-year-old to focus on his distant learning while trying to work. It's all, but again, we're all in it. Every single person, whether it works at working with me at MCN or around the world, actually. So again, it's been the first reaction was to understand that it's a global issue. And then react quickly and lead. And part of that was making sure that our people were safe. Once we understood that construction was going to be deemed essential and we're going to be asked to continue working, our efforts went into making sure that everybody at our job sites is essentially operating in the most safe way possible, regardless of cost. And very quickly, our safety team turned around protocols for the job sites, from temporal scans in the morning to essentially even resequencing work so people are not stacked on top of each other and everything in between. And now we have a standardized protocol across the different job sites.
Raj, I know Joseph has a couple children. Do you have school-age children?
I do. I have a freshman 14-year-old and a 6th grader, 9-year-old, and they go to charter schools.
Oh, excellent. What concerns do you have for them when they go back to school?
We do a lot of discussion within my household about this, and we are going to get the mandate from the mayor, from the school district. You're going back to school. And at first I was very, nervous about it. Like, they haven't made any retrofits, and I'm talking to their school. So let's get this air quality improved. But as things start to go over time, the mental health of my kids it's going to deteriorate if we don't get back to school. And I already see it with my elder son. He's getting a little bit more depressed, a little bit more insular. And it is a very, very important. The work we're all doing here is we got to get these kids back to school. Nothing's going to be perfect, but the longer term repercussions of staying at home, I think, are worse than if we don't try to minimize and start to look at the air quality as one of the ways to stop this.
And what advice do you have for school leaders and board members who may be watching, and as to what they should be thinking about?
I mean, on the personal level, my expectations are again set to where there's nothing that's perfect. Like, I expect my kids to go back to an environment that's as safe as possible. There's a lot of measures that are being discussed out there in terms of prepping schools to receive a big chunk of the kids back, whether that's in a cohort system where there's a bunch that's going to school 1 week and then the next bunch the following week, or it's fully back to normal. Buildings can be essentially retrofitted to do better. Our existing contingent of buildings could use another fresh set of eyes, whether it's touchless entry points, touchless urinals, and plumbing fixtures across the facility, a lot more sanitization stations across. The way we look at our HVAC systems, and obviously Raj will talk about that in a bit as well, whether it's through UV sterilization or better essentially filtration as well. And in my day-to-day, because I focus a lot on pre-construction, it's really trying to understand what gives us the best bang for the buck, because obviously, and particularly in a charter environment, we operate on a very, very tight budget, and we want to make sure that whatever we're implementing from the 100 different things that are floating out there give us the best bang for the buck and the safest environment.
You've both worked with hundreds of schools. What is the best practice that schools should follow in order to reduce the risk and create the safest possible school environment this fall?
So in an existing facility, Raj has and his firm have published a guideline, and he can talk about that in a second, into how we can retrofit existing facilities to allow for COVID or best practices. In my day-to-day, what I've been concentrating a lot of my time on is understanding, again, what is the benefit out of each one of these different approaches, what gives us, again, the most bang for the buck, and how do we prioritize?
That's actually a good transition to Raj in that you have been you're working to opening schools right now, and and building hope as a developer and investor in schools. We're opening schools, and I think we're learning too that as you opening a school is one thing, but there's also a whole bunch of buildings that are already open and under operation, and that there's things that we could do to ensure and lower risk of the spread of COVID. And Raj, you have been kind of a thought leader in the world with respect to MEP systems and really the airborne issue of COVID in the air. I'd like to focus in on that for a little bit, if you don't mind, because I think that after reading a lot of the materials, I think there's things that we know people could do to reduce the spread. If the aerosols are building up and the air conditioning system is not moving, I mean, what can schools do to change that process? Because if air is not moving, right, that's a greater risk.
If air is not moving, it is definitely a greater risk, and you're going to start to get that plumes and stagnation within a room. If you think about what is the ideal classroom, if I want my kids to go to classroom, I want it to be outside, everyone's 10 feet apart, nice gazebo, quiet environment. So how do we start to replicate that same environment in the classroom? And that's what we're trying to get to. The air's not moving. That's step one. Let's get the air moving. So then we want to get to the filters. And if I know the virus size, we're going to call it about 100 nanometers. Then if I have a current filter of a MERV6 that's at 1,000 nanometers, then I know the virus is going to go through. So when we say change the filters, is go to a filter with a tighter mesh, and that's what it is. And that tighter mesh starts to pick them up, and so they don't get through. And then when they're aerosolized, we have a better opportunity to pick those up in the filter. We look at 6 air passes every hour, every 10 minutes, and then we start to pick up more and more. You don't pick them up all the time.
It's sort of like being outside with the wind blowing all the time is kind of the ideal scenario. Is that fair?
Exactly. I mean, that's what we'd all want for our kids, right? This is the dilution, which is more fresh air. Why do we want more fresh air? Because it probably doesn't have the virus. That's the point of it. If we can go with 100% fresh air system, then do it. Then if you can't, then let's try to filter that air. And then this third tertiary step is just to disinfect, kill it, UVC. We have lots of technology that's been used for decades to kill mold spores for mold growth and bacterial growth, and now we're just reapplying it here in the UV with the UVC. UVC is generally gets blocked by the ozone in the atmosphere. It's 200 to 280 nanometers. And now we're just reintroducing that inside of a unit, and it just kills everything. So that's we have hope here. That's the key. We have lots of tools we can start to deploy.
We have hope, and we can continue to increase the airflow in the classroom if the schools will take your advice and start to fine tune their systems right now.
That's it. And one of the biggest things, if you take anything away from this, is make sure that when folks are changing filters, it's going to be counterintuitive because they'll be alone, off hours, but they have to wear PPE, the highest grade possible. The last thing you want is someone who has the virus and sneezes while they're doing the filter, because those central systems will redistribute it within the system. So hopefully your listeners just that little thing, wear PPE in those mechanical rooms, on the roofs too.
So Raj, you can really live in an air conditioning system for 72 hours?
So let me be a little bit more clear on that. So we are fairly confident, this is the scientific industry, this is different research, that the virus can become aerosolized. It can stay alive in the airstream. So HVAC systems are moving lots of air. The entire building air will go through that mechanical system anywhere from 2 to 6 times an hour. So now we have this virus that is staying alive, aerosolized, whether it's in water molecules or in what form. So it is now going to get sucked back into the main HVAC systems and then redistributed. It is staying alive in the air. So now in an occupancy mode, an unoccupied mode, you shut the unit off. There are studies showing of extended life on stainless steel, on plastics, and a couple other surfaces, and I can share those studies as well. So that's what we're taking that scientific research and saying, okay, we feel fairly confident that it can get redistributed and not killed pretty quickly. So that's how we start to take those engineering applications of heavier filtration, more fresh air to dilute it, and then of course the UVC. So that's the mindset.
There's the idea that a school could work with Setty, a school could work with MCN Build, right, and start some preventative measures now that would help improve the air quality, correct? And also though that there's the other part of it, which is if there was an infection in a classroom. And so I think sometimes we blend those two discussions, and so I wanted to really kind of focus in on, let's talk about the before, right? What are some steps that schools can do before? And then let's shift over to what happens if there's a student or a teacher or a faculty member, any faculty member that might have, some type of infection. So take me through the pre and then the post.
Here's how it goes. Currently, we have about 4.5 million square feet that buildings, whether it's commercial, government, and schools, that we're assessing. We want to see where you stand, what tools you have, how much fresh air you're building. Step one, nothing is perfect, but how do we start to reduce the risk of the virus transmitting? So what we're recommending on things like temperature checks is switching to an app type format. There's multiple apps out there. We push that liability, we push that responsibility to the parents. You take the temperature of your child at home. If they are sick, they stay at home. That's step one, going all the way to the pre-before. So they do not get on that bus. They do not get even to the front door. As we work with the different school systems, it is, okay, now I've got someone who has an elevated temperature. Now what do I do with them? So first step is keep them at home. They run through checks. They email the school, and the checks and things have to be done within 35 minutes to 1 hour before they enter, creating like a TSA pre-clear, pre-check, for lack of a better term. So now once we get to the school and you do have a sick child or an event where you have someone sick, We are looking at isolation rooms for infection, which is right now we're converting multiple of these at their nurses' suites, or we're looking at setting up temporary. But that is an inevitability that you'll have a sick child. So we want to get them into these isolation suites and ensure that your HVAC system does not spread this around. Of the 40 schools I've looked at in the last month, most of them are hooked up to the central system. So it's an easy thing to stop. So now we're going to have the sick child. We're going to start to mitigate the virus right there, and then their parents pick them up. And then your final kind of thought is 6 months from now, 1 year, the simple question is it working? Okay, you got your dilution. Do you have your UVC in place? You've got your filters in place. Is it working? So we're coming up with those benchmarks. We're modeling it. The airflow, not to get too arcane, but with the Wiles-Riley equation, you can start to model how these viruses move around spaces, and basically we got to just drop the number of them so they don't reproduce, and that's the methodology. Last point on this, Drew, is we are seeing a lot of migration, and it's hard to disinfect on shoes. So some kid spits outside, and then someone steps in it and tracks it in. So I am pushing heavily for sanitizing mats. There's a couple studies in China where they are showing that migration fairly deep into the buildings on shoes, and it's not a place where the air systems hit very well, nor do we disinfect carpets and things very well. So hopefully that's a little bit of a tidbit that your listeners can get out of this.
Joseph, is there a particular example, or Raj, is there a particular example that you're working on right now where you could kind of describe what a school is asking for and what you're delivering?
Sure. There's a school right now where we take your plans, we do an HVAC and an entire score on your school, give it a letter grade from A to F. Then we start to look at your systems in there. So we want to increase the fresh air. This school had about 20%, so it is very costly to increase the amount of fresh air. So we will run it longer, 2 hours before and 2 hours after school. That's a way to operationally bring in more fresh air. The filters. We want to go to a MERV 13 filter. What's the side effect on the filter? You have harder pressure to overcome and deliver the air. Now that generally is going to happen at peak conditions. So we have two things we can do. We can adjust the motor speed, and we can also adjust the discharge temperatures, because we, in essence, want to get a certain amount of cooling. In a space, I can only do two things: change the temperature or change the amount of air. So since I'm going to reduce the amount of air, I'm going to adjust the temperature settings, and that gets us the same place. So when we are really pushing, coming from a logical engineering perspective, to get the right plan. It's easy to replace equipment, but that's not going to be cost effective.
Does the temperature of a classroom or a building matter to the spread of the virus?
There's a New England Journal study that the temperature is not as much of a factor for viruses in general. So this is the type of virus this is an enveloped virus. And so that's typically the studies you want to look at versus a small non-enveloped or a large non-enveloped. So what you're seeing with these viruses is that the transmission starts to plummet when you get between 40 and 60% relative humidity. So we are trying to stop the transmission with the relative humidity, but you are seeing currently in different states with high temperatures that transmission is still occurring. So it's anecdotal, but we do not see much of a variance with temperature. So it's really about the relative humidity that we want to focus on.
What I would like to do, though, is understand a little bit about what it's like. What are the conditions? From my understanding about building mechanical systems in Washington D.C. and maybe cities like New York and Houston and L.A. and in larger cities, you're building to more of a green building environment. So there's commissioning and there's a bunch of other things that you need to think about for peak performance or efficiency within your HVAC system. Around the country, there are schools in different environments, right? There are rural schools. There are schools that in suburban schools with, rooftop units. Maybe, one unit controls 2 rooms. Could you talk a little bit about, weaving in to your example of what you're working on in DC to how that is relevant to some of the other types of schools that are out there?
Sure. And we are doing schools in New York, East Coast, Georgia, so a lot of it does apply. There's 8,760 hours in a year, 8,760 hours. So buildings are designed to consume energy, but we really want to make sure that that environment is safe. That's first and foremost before we move into the energy efficiency. So what we're doing is focusing on those other 6,000 hours when it's unoccupied, weekends, nights, and we'll still be able to save energy at that point. Now, with my work with ASHRAE, which is the main nonprofit organization that's putting out all the technical standards, we're looking at a lot of these retrofits and changes as temporary. We want to run these units in a pandemic mode, bringing in more fresh air, more filtration. We do not want to sacrifice energy efficiency, but in the short run, there is going to be a trade-off, and it should be done operationally before systems are ripped out. We'll look at focusing on still turning lights off, looking at energy efficiency on the motors, sequencing. We're going to have reduced occupancy in DC schools, as an example, 9 kids and 1 teacher. So now how do we can adjust for that by having more fresh air come in, keep that high indoor air quality, but we don't have to have the same amount of temperature. We can probably supply at maybe 60, 65 degrees versus 55 because we're a third occupancy. So I am fairly optimistic if you do this right, controls and the sequences, we are going to be able to maintain energy and in some cases save energy while improving indoor air quality because we're looking at these reduced occupant levels.
I'm learning as we go here, and really appreciate you taking us through that. And I can't help but think, Joseph, from your side of it as a contractor, do you test your subcontractors and before they would come into a building?
We have to keep our own staff safe for and foremost. And we've been deemed essential. We haven't skipped a beat, although everybody that could work remotely when we were talking about flattening the curve have done so. Our superintendents, our assistant superintendent, and our managerial folks have not stopped reporting to work on a daily basis. So again, we had to react very, very quickly and implement very stringent measures from the get-go to protect them and their families. Particularly when you're asking, which is a very, very hard proposition for us. You're asking a part of your team to report to work and be at the front line, where the others, including myself, we're working from home because of just the nature of the work that we're doing. But the bottom line is that the first thing that we're doing is everybody has to go through a queue with social distancing to get their temperature checked in the morning. We are acquiring cameras that have that capabilities, so we can automate some of these functions. We have eliminated the communal eating areas and food trucks coming up to job sites for the time being. We have resequenced work again to allow for work areas to be less congested. And this is when you're delivering a school, you know that you're working in every square feet that you can just to get ahead of schedule. But we've had to resequence work and then essentially extend the workday and find other ways, inventive ways to not have 10 people work in the same room at the same time. We have put in more sanitization stations throughout the buildings. We have done the same. We've required the same protocol from our subcontractors. Well, coming into the site, they have to report on their health before they walk in. And then also had in place stringent protocols on what happens if there's an infection. If somebody reports positive, what do you do then? And again, have everybody well-versed and trained on what to do in these circumstances.
Thinking about going back to school and being someone who is opening schools, you're building them. You guys are in this, and I think that school leaders want to educate kids. Would you ever advise a school not to open? Depending on certain circumstances, maybe they don't have protocols, et cetera. How have you ever thought about that question? And do you think maybe in some places we're opening too soon?
It's all about risk mitigation, 3 levels of risk. So at a bigger picture, I would love to see us get rid of summer, go to school in the summer, and then take a longer winter break, 2 to 3 months. We know more people get sick at home anyhow, and you're already seeing that with higher ed where they're going to go virtual in the fall. So that's more of a structural mental shift. The second one is when it happens in the classroom, which it will. As a parent, I would like to know that someone did test positive in my daughter or son's classroom. So we need to have some level of contact tracing. Along with that, and we're walking through multiple school districts on how to write that protocol. So then we say we disinfect the room, wipe it down. The room becomes isolated till we hit anywhere from 20 to 30 to 40 air changes where all the air hits a filter, hits a UVC, or gets disinfected. We bring in portables so we know we're cleaning the air in the room. You will have 2 choices. You have 14 days to keep everyone in that school, in that classroom out, and then maintain the other classrooms if you have some level of contact tracing, or you shut the whole school down for 14 days and go virtual. So those decision points are pretty clear of what you're seeing. And with our clients, they're like, well, we don't want to shut the school down. So how do we isolate it to that room? You're not moving the kids around. That all makes sense. So as soon as you get the sick kid, then those 14 can either go to a special isolation suite for class, or they work from home. But you have to have those systems in place, like those portables, and then just the simple protocol showing like this is what we did and we feel comfortable about the mitigation of it. And then of course all parents will have their option to keep their kids at home. But that's where we just need a little bit more common sense before we go and turn these all into fume hoods that we learn under.
Your company set up an assessment for schools to use?
Correct. So to make things simpler, because it is a lot of material to try to digest and to get through, we end up looking at 5 or 6 different categories, and you get points assigned to each line item within those categories based on risk. If you want an A for your school, then it is going to be very similar to a hospital where we have very little migration and we have a tremendous amount of infection control. So this is a simple spreadsheet, and it helps to frame that conversation of where to make decisions and not to make decisions. You can go touchless in all of your fixtures in a bathroom, but you can also just turn off 3 out of 4 and just go touchless with 1. So the basic common sense type interim approaches is what a lot of our clients are looking at, and it is skewed heavily towards that indoor air quality, nurses stations, because we find those things very important to get to. Do you have protocols? And it does give that frame of reference on how to start thinking through it and writing it up. Everyone's in the exact same boat, and that's why we help to create and standardize this scorecard. I'm currently with ASHRAE. I instruct other engineers. I did about 1,500 other engineers a couple weeks ago on how to reopen schools and start to get this game plan together. So I take a lot of that feedback from those other engineers and architects and facility managers and put it back into this spreadsheet. It's the parallel is like a LEED checklist or an ASHRAE audit checklist. So when we have that tool, it puts that framework into making the decisions.
Well, I think people are engaging MCN and Setty because they want a protocol, right? They want a new system, some type of design thinking around how to reduce the spread and what to do when it happens. And I think that they're in good hands when they have people who are thinking it through from end to end, like MCN and like Setty. So I really want to thank you both for talking with me today. I hope this was helpful to our listeners. You really are bringing up issues that I think are complex. I think there's a lot of little pieces, and there are different budgets for different schools around the country, and there'll be different protocols, and there'll be different comfort levels for different schools, different boards, and different families. And so I think everyone should have the information. and ask questions. And please reach out to us or look at the Charter Conversations website, or look at the MCN website or to the Setty website to learn more about them and their work and their market. So thank you for joining me today, and we look forward to seeing you next time. Thank you for joining us today. For more information, please visit charterconversations.org.